Dear students, in the last class we have taken the definition of Laplace transform and also we obtained the Laplace transform of some elementary function, whereas we have taken the Laplace transform of t power n exponential function, trigonometric functions such as sine and cosine function, hyperbolic function, and also we have seen the Laplace transform of e power at into f of t, t into f of t, t square into f of t, the division that is f of t by t. Hope you have all those results and I hope you are able to apply wherever it is required, and also I think you have solved all those problems which we have taken in the exercise section. So today we move on to the next concept where we take the Laplace transform of special functions, in which we have to take the Laplace transform of periodic as well as unit step function. So let me take the Laplace transform of periodic function. First of all, when we can say a function is periodic, I hope you know that a function f of t is said to be periodic with say some period capital T whenever f of t plus t is equal to f of t. For example, sine function. The sine function I can say it is periodic with the period 2 pi because sine of 2 pi plus x equal to sine x. Now, so whenever a function is periodic, then I can write its Laplace transform by using the formulae or algorithm L of f of t is equal to just multiply f of t by e power minus st and integrate with respect to t between the limit 0 to capital T, that is period, and multiply this by 1 over 1 minus e power minus st. So you have to remember this. So just multiply after getting the integral of e power minus st f of t between the limit 0 to t. So now we can move on to the next some problems. We can take some problems where we can find the Laplace transform of periodic function. So let me take the first problem. Find Laplace transform of f of t. Here it is given k in the interval 0 to a minus k in the interval a to 2a. How to find the Laplace transform wherever it is periodic? We can first identify the capital T, that is periodicity, and substitute in the formulae. So the solution is here goes like this way. T is 2a, Laplace transform of f of t. I can multiply the f of t as usual by e power minus st, integrate 0 to t between 0 to t and multiply this by the factor 1 over 1 minus e power minus st. So just substitute as it is, but while integrating we have here split up because the function is discontinuous. So we have to integrate 0 to a by taking k into e power minus st and integrate between a to 2a by taking minus k into e power minus st. Since k is a constant, I can take it out and we can just integrate e power minus st, one between 0 to a, another is between a to 2a. So what is the integral of e power minus st? It is simple. So integrate it e power minus st by minus s and apply the limit upper limit minus lower limit. So this gives k by 1 over 2 1 over e minus 2as is constant anyhow. So apply the limit, upper limit is a minus lower limit. So we have minus 1 over s is anyhow constant. So e power minus as minus e power 0, that is 1. So multiply that minus 1 over s. So we get e power minus as by s minus of minus plus 1 by s. Similar work we have to take for the second term also. We get e power minus 2as by s minus e power minus as by s. So if I further simplify, then I can take 1 over s, anyhow s is in LCM, it is common, take it out, k by s into 1 minus 2 e power minus as plus e power minus 2as by 1 minus e power minus 2as. So I can simplify this by observing the numerator. So the numerator is anyhow in a form of a minus b the whole square, where a is e power minus as and b is 1, or I can make simple, make it simple for our convenience by taking x equal to e power minus as, then it looks like 1 minus 2x plus x square by 1 minus x square. So numerator is 1 minus x the whole square, denominator is a square minus b square, thereby I can write it as 1 minus x into 1 plus x. So where 1 minus x gets cancelled from both numerator and denominator, leaves back 1 minus x by 1 plus x. So that means get back x, so it is e power minus as. So I get 1 minus e power minus as by 1 plus e power minus as. So here we get k by s 1 minus e power minus as by 1 plus e power minus as. Now students, I hope you remember that 1 minus e power minus theta by 1 plus e power minus theta, 1 minus e power minus theta by 1 plus e power minus theta is tan hyperbolic theta by 2. Here we have in place of theta as, so substitute back, we get k by s tan hyperbolic as by 2. So shall we move on to the next problem? So the next problem, here we have f of t is given as t in the interval 0 less than or equal to t less than or equal to a, 2a minus t in the interval a less than or equal to t less than or equal to 2a, and f of t is mentioned periodic with period 2a. So I have to find the Laplace transform for this function. Obtain first period, identify period is here 2a, substitute in the formulae, that is 1 over 1 minus e power minus st integral 0 to t e power minus st f of t dt. So I have substituted it, that is here I hope we can integrate t e power minus st under the limit 0 to a, 2a minus t e power minus st under the limit a to 2a easily, either by integration by parts, okay. But since here associated is a polynomial, whenever polynomial into any function is there, we can go for Bernoulli's, so which is nothing but of the type integral u v dx, where u is a first function, take it as a polynomial. So whenever polynomial into any function, you can go for u v1, where v1 denotes integral of second function, minus u dash v2, that is first derivative of first function, second integral of second function, twice again we have to integrate v2, continuously integrate and differentiate here afterwards by alternatingly taking plus and minus and plus. So the third term is plus u double dash v3. So thereby I can write the next step is 1 over 1 minus e power minus 2as t into integral of second e power minus st by minus s, minus derivative of first, that is derivative of t is 1. So I have this 1 into e power minus as by minus s, but already we had minus s, so minus s into minus s square. Apply the limit, upper limit minus lower limit, that is 0 to a. Similar work for 2a minus t by e power minus st, integral is 2a minus t into e power minus as by s, integral of second, minus of derivative of 2a minus t is 0 minus 1, because 2a is constant, derivative of minus t is minus 1, already outside minus in the formula, minus of minus plus. So I have 1 into integral again e power minus st by minus s, already earlier minus s is there, so it is s square. Apply the limit a to 2a. So the next step, substitution. So after applying the limit, I have here carefully apply this. So now further you can simplify by taking s square as LCM. So I did it. So if I take s square as LCM, so we have 1 by s square, we can take it out. Numerator now simplifies to 1 minus 2 e power minus as plus e power minus 2as divided by 1 minus e power minus 2as. Now again the same way we can simplify by taking numerator in the form a minus b the whole square, denominator is a square minus b square, so one term gets cancelled, so it gives 1 minus e power minus as by 1 plus e power minus as, where again it is of the form 1 minus e power minus theta by 1 plus e power minus theta is tan hyperbolic theta by 2. So here theta place we have as, so that's why it is tan hyperbolic as by 2. So the Laplace transform of f of t in this case 1 by s square tan hyperbolic as by 2. So let us take one more. The last problem we have here is a continuous function. We have taken one continuous function, that is e sin omega t, defined in the interval 0 to pi by w, and obviously here it is mentioned again, it is periodic with the period pi by w. So t is pi by w. If I want Laplace transform of periodic function, use that formula again, substitute where f of t is e sin omega t and the limit is 0 to pi by w. So definite integral is 0 to pi by w. So we have e by 1 minus e power minus pi s by omega integral 0 to pi by omega e power minus st sin omega t dt. Now how to integrate this? So how we can integrate e power minus st sin omega t? Here we cannot use the Bernoulli's rule because none of these two are polynomial. So we have to use some other method. Obviously here we have one result, standard result, we have exponential at sin bt, e power at sin bt dt, we have the result. So we can apply that, e power at by a square plus b square, a sin bt minus b cos bt. So in place of a here we have minus s, in place of b we have here omega. So we have the next step becomes e by 1 minus exponential minus pi s by omega into e power minus st by s square plus omega square, because it is a square plus b square, that is minus s the whole square plus omega square. So we have clearly it is s square plus omega square. A sin bt, now it is minus s sin omega t minus b is omega cos omega t, apply the limit 0 to pi by omega. So if I apply upper limit first, so take very carefully, we have not only sine and cosine function, we have e power minus st, limit for s, so apply that. So e power minus st sin omega t, but while applying upper limit sin omega into pi by omega, that is omega cancel, sin pi. What is sin pi? Sin pi is 0. Again when lower limit it is 0, sin 0 is 0. So that means, so anyhow sin omega t exponential minus st vanishes after applying upper as well as lower limit. So I can take only for cos omega t. So what is the answer? If I apply the limit pi by omega cos omega pi by omega cos pi is minus 1. So outside e power minus pi s by omega. Similarly when we apply the lower limit, it is cos 0, it is 1, outside we have exponential 0, that is also 1. So the next step, it gives exponential e by 1 minus exponential minus pi s by omega into omega e power minus pi s by omega plus omega by s square plus omega square, or you can take omega constant, anyhow we can take it out, e omega by s square plus omega square into 1 plus exponential or e power minus pi s by omega by 1 minus e power minus pi s by omega, which is nothing but earlier we have taken 1 minus e power minus theta by 1 plus e power minus theta is tan hyperbolic. Here it is a reciprocal, 1 plus e power minus pi s by omega by 1 minus, so it is cot hyperbolic. So I have this is the answer, e omega by s square plus omega square cot hyperbolic pi s by 2 omega. So we have taken 3 problems under periodic function. I hope we can now move on to the next, that is Laplace transform of unit step function. So what is unit step function? Let me define unit step function first. So unit step function is defined as, let me take unit step function, or it is called as Heaviside function. So I can call it as Heaviside function or unit step function. So it is defined u of t minus a, where a is any positive value. U of t minus a is nothing but 0 up to a, that is 0 less than or equal to t less than a, and it is constant throughout later on, that is 1 for t greater than or equal to a. So the graph is shown here, it is this way. So up to a it is 0, then it is constant, that is later on a onwards, a to infinity it is 1. So it looks like a step, that means it is off then on. So up to a it is 0 and then it is 1. In such case, what is the Laplace transform? For unit step function, the Laplace transform is nothing but we can obtain just by applying the definition. Also we can get the result, that is L of u of t minus a is what? You have to integrate given function by multiplying e power minus st and integrate between the limit 0 to infinity, but 0 to a it is 0, so a to infinity is 1. So I have to just integrate e power minus st into 1, that is e power minus st between the limit a to infinity. If I integrate, I will get the result u of t minus a, Laplace transform is e power minus as by s. So that means if I want u of t minus 3 where a is 3, then it is e power minus 3s by s. So if I have unit step function with the any function of t, or we read it as actually f of t minus a. So the result says Laplace transform of f of t minus a into u of t minus a is, first find f of t, that is obtained by replacing t by t plus a. So that means if I have here f of, always we read it as f of t minus a, get back f of t just by replacing t by t plus a. Once it is obtained, write the Laplace transform or obtain the Laplace transform, multiply it by e power minus as. So identify a, e power minus as. But for our convenience, so I can rather depend on this result, simplify this. So same result we have reduced it. So I read always as a f of t itself. Whenever a function is there along with the unit step function, I take it as f of t into unit step function. So e power minus as into Laplace transform of, as you know that we have taken here f of t by replacing t by t plus a, that itself I have written here. So Laplace transform of f of t plus a. So I remember this result always. So that is Laplace transform of f of t into u of t minus a is Laplace transform of f of t plus a and multiplied by e power minus as. If the function is discontinuous, for example if I have breakup, there is a breakup, f of t is defined in the interval 0 to infinity such a way that it is f1 of t in the interval 0 to a, later a to b it is f2 of t, and b onward, b to infinity it is f3 of t. How to get the Laplace transform? So in such case we have to first express this in terms of unit step function, which can be written f of t is equal to f1 of t, that is first term f1 of t plus f2 minus f1 into u of t minus a, t less than a here. So u of t minus a plus one more term is there, that's why f3 minus f2 in the interval, sorry, f3 minus f2 into u of t minus b, u of t minus b. That means Laplace transform of f of t is of the type L of f1 of t into L of f2 of t minus f1 of t into u of t minus a, where I can now use the previous result. Wherever u of t minus a into any function is there, we can first write the Laplace transform of a function which we obtain after replacing t by t plus a. So that's how we have written here. First is as direct form Laplace transform of f1 of t, but the second one is e power minus as into Laplace transform of, not directly we have to write, no need to, you should not write directly, we have to first replace t by t plus a, correct. So I have written L of f2 of t plus a minus f1 of t plus a, whereas in the last term it is e power minus bs, L of f3 of t plus b minus f2 of t plus b. So we can take some results, sorry, problems. The first problem here, find the Laplace transform of following function by express them in terms of unit step function. The function is given cos t in the interval 0 to pi, cos 2t in the interval pi to 2 pi, cos 3t in the interval 2 pi to infinity, t greater than or equal to 2 pi. The solution is, first you have to express this in terms of unit step function as usual, cos t plus cos 2t minus cos t into u of t minus pi, because it is here, and cos 3t minus cos 2t into u of t minus 2 pi, t less than or equal to 2 pi. Now take Laplace on both sides. L of f of t is equal to L of cos t, directly I can write, but L of cos 2t minus cos t into u of t minus pi, we have to write e power minus pi s, correct. L of cos 2t minus cos t, don't take directly but replace t by t plus pi, that is cos 2 times t plus pi minus cos of t plus pi. Similarly last one is e power minus 2 pi s Laplace transform cos 3 times t plus 2 pi minus cos 2 times t plus 2 pi. So what is cos 2 times t plus pi? That is cos 2t plus 2 pi. Cos 2t plus 2 pi or cos 2 pi plus 2t, so it is 360 plus, so cos 2t, and cos pi plus t, that is 180 plus t, that is 90 into 2, even multiple means cos t. 180 plus means in the third quadrant ASTC rule says tan and cot are positive, cos is negative, so I have minus cos t, so I get Laplace transform of cos 2t plus cos t. Similar work for the last term, cos 3t plus 6 pi, 6 pi means 3 full rotation, so I have again cos 3t minus cos 2t plus 4 pi, so where we have 4 pi means again 2 full rotation, so that's why it is back to cos 2t. So apply the result directly now. You know cos at result, s by s square plus a square, here multiplicity is 1, so s by s square plus 1, rest all similar way, e power minus pi s by s square plus 4 plus s by s square plus 1, e power minus 2 pi s by s square plus 9 minus s by s square plus 4, correct. So next, to find the Laplace transform of f of t, it's very simple, algebraic, so polynomials, 1 in the interval 0 to 1, t in the interval 1 to 2, t square in the interval t greater than or equal to 2. Express in terms of unit step function first, written, and apply Laplace on both sides, correct. L of 1 into L of t minus 1 u of t minus 1, I have applied the result e power minus s into, after replacing t by t plus 1, I get Laplace transform of t only. Similar work for the third term also, e power minus 2s, Laplace transform of, replace t by t plus 2, in this case t plus 2 the whole square minus t plus 2, simplify that, then we get L of 1 L of t into e power minus s, e power minus 2s into L of t square plus 3t plus 2, expand that, so we get this. So now it is term by term Laplace transform, so L of 1 by s, e power minus s by s square plus e power minus 2s into t square, Laplace transform is 2 by s cube, 3 times Laplace transform of t is 1 by s square, so 3 by s square plus 2 times Laplace transform 1, it is 1 by s, correct. So very simple, can take one more, the last one problem will take, it is cos t in the interval 0 to pi, 1 pi less than or equal to t less than or equal to 2 pi, sin t for 2 pi less than or equal to t, or t is greater than or equal to 2 pi. First we have taken Laplace transform, before that we have to write, express in terms of unit step function. Take the Laplace transform on both sides, L of cos t plus e power minus pi s into Laplace transform, don't take 1 minus cos t as it is, replace t by t plus pi, so that's why it is cos t plus pi. What cos t plus pi, you have to write, simplify, that gives a minus cos t, so minus of minus plus cos t. So the third term is e power minus 2 pi s sin of t plus 2 pi minus 1. So what is sine of 2 pi plus t? That is sine t only. So we get finally Laplace transform of cos t plus e power minus pi s into Laplace transform of 1 plus cos t plus e power minus 2 pi s Laplace transform of sine t minus 1. Substitute, apply the results. So it is L of cos t s by s square plus 1 plus e power minus pi s, L of 1 by s plus L of cos t s by s square plus 1 plus e power minus 2 pi s, L of sin t 1 over s square plus 1 minus L of 1, that is 1 by s. So we stop here. What we have taken in today's class, we can have a look on it. So here we go. What we have taken is, we have taken the Laplace transform of f of t, where f of t is a periodic function. So remember that result. And for unit step function u of t minus a, the Laplace transform is e power minus as by s, and whenever it is associated with the any function into unit step function, e power minus as into Laplace transform of f of t is replaced by t plus a. And in case of discontinuous function, we have to first express in terms of unit step function and then apply Laplace transform. By using the result which we have taken in 3, we can get the Laplace transform of those terms also. So thank you for patience listening. Go for all these exercise problems, try to understand the concept. If you have any doubts, you can clarify in the next class. Thank you.